All right, so defrost is one of those things that gets overlooked a lot on heat pumps, especially testing it. And to be frank, if you live in a market like Florida, you know, they don't need to defrost that often, so you can get away without testing them. But it really should be part of the standard protocol of maintenance and service, making sure that the defrost board is going to work properly, testing the sensors and all that. So today, Jesse's going to go over real quickly with you how to do it on a Carrier, and then Bill's going to talk to you a little bit more about how to do it on a Trane, because he's our resident Trane expert.
Here we have our defrost board. Couple things to note. The outdoor fan motor hooks up to this relay, your defrost or your coil sensor. So this is sensing the coil temperature, letting the board know when it needs to go into defrost. If you trace this back on a Carrier system here, the defrost sensor connected to the outdoor coil right here. Again, if you follow these pink wires back, that's going to be testing the coil temperature periodically. Once this has become frozen cold enough, it's going to force the system into a defrost. When it goes into a defrost, a couple things happen. It sends 24-volt signal to our reversing valve, switching the cycles from heating to cooling. It's going to shut off the outdoor fan motor to allow the outdoor coil to defrost significantly quicker. And at the same time as it's doing all of that, we're going to be sending a 24-volt call on our white wire, which will activate our backup heating or our auxiliary heat strips to allow the space not to cool down too quickly. Hopefully it's just a neutral. You don't gain anything, you don't lose anything. Depending on the kW size of the heat strips will be a big factor in that. And then here you are going to have a setting. You can set it for 30 minutes of defrost, 60 minutes of defrost, or 90 minutes of defrost. Depending on your location, we'll probably factor the setting that you require. We are currently on 60 minutes of defrost. So we're gonna put the unit back together. We're gonna force it into a defrost cycle. You have a speed up tap over here to speed up the process for testing. Again, this is on a Carrier. There's a lot of variables based on the equipment type and the manual, and we'll go over some of that as well. Right now we're running in heat mode. If you want to speed up the defrost testing cycle, you can jumper out the speed up. Again, that's going to speed up the process of it actually testing to see if it needs to go into defrost. It's not actually going to force it into a defrost. Again, we're working on a Carrier system. It's going to be different depending on the brand. That being said, we still want to test it out in defrost to confirm that everything's working properly. Our defrost sensor is normally open, so you can't just unplug this and have it go into defrost. You actually need to unplug your defrost sensor, and then you're going to need to jumper out your defrost sensor, and then you're gonna need to go to the speed up tap and actually speed up the process. So right now we have it jumpered out so that it thinks that it needs to go into defrost. Now we're going to actually go to the speed up tabs here and hold them down for the required 12 to 24 seconds based on the settings. This one's on 60 minutes, so it should be about 12 seconds. So now it's in defrost. What happens is it switches the reversing valve. So now that we're putting all that discharge gas into our outdoor coil, which is going to melt the ice. At the same time, we're shutting off our outdoor fan motor to prevent any air movement over that outdoor coil, speeding up the defrost cycle. At the same time, we're also sending a 24-volt call on our white wire, which is going to force our heat strips on the outside. Now, if you want to speed up the defrost process, since we're just testing it out, you can hold this down for, it's approximately 2 seconds, forces it back out of defrost. Reversing valve now switches back to your heat mode, drops our 24-volt call on here, and re-engages our fan motor. And that's the defrost process. That's the defrost board, what it does. Again, here's your fan relay, which can drop out the fan motor when it's in defrost.
All right, so this is the Carrier Defrost Thermostat, and as you can see, this will close at 30 degrees, plus or minus 3 degrees, and then open again at 65 degrees, plus or minus 5 degrees. And so closed, or in this case, jumpered, is the indication that the coil is frozen and ready for defrost.
So So hopefully that was beneficial. Whenever I'm doing one of these videos, it's amazing. I actually learn stuff as I'm going through it, figuring it out. Oh, you don't do that, you do this. So little things I've learned today as well. One last thing I wanted to mention is down here, if you're checking your discharge temperature, you're just gonna clamp a temp probe onto what is now your discharge line in heat mode. That'll get extremely hot. Usually it's right around 90 to 100 degrees over ambient, so over your outdoor temperature. That's also a good indicator. This one was really nice because it had what we were looking for based on the tonnage and the indoor and outdoor conditions, what we were looking for on our discharge line, and then what we were looking for on our common suction line. So we're just gonna go over some differences on the Carrier equipment that we went over today. Bill's an expert with Trane, essentially. He's been working for 20 plus years with Trane equipment, so knows it pretty inside and out. So we're gonna go over a couple of differences. First question I have is Defrost Board. We went a lot over that process on the Carrier equipment, how to test it and defrost, how to force it to defrost. What differences are there from the Carrier to the Trane?
So Trane defrost is actually very, very simple. You have two different sensors here. You have one for the outdoor ambient sensor. It tells you what the outdoor ambient is into the board with the resistor, and also your defrost, your coil temperature. But coming from your defrost board, these yellow wires trace back into a little tube. Inside that tube, they put the little resistor inside there and zip tie it in, and that reads the coil temperature. Much like the clicks on that's in the Carrier system, but it's actually read by resistance. There's 3 test pins, and you just jump the test pin out. It's almost immediate on a Trane that it'll go into defrost. Depending on how cold it is outside or how warm it is outside will depend on how long it's in defrost. Trane will actually stop the defrost cycle once the coil temperature is back well above freezing, and it realizes all the ice is gone.
The Carrier, as soon as it goes into a defrost, if I'm correct, it's going to be in defrost for a full 10 minutes, unless if we're jumpering out the speed up pins, which would speed up that process.
All right, so I want to cut in here real quick. You can see this is the information for the Carrier defrost sequence for the kind of the standard Carrier defrost board. And it does automatically run for 10 minutes if the coil never gets above 65 degrees, plus or minus 5 degrees for the defrost thermostat to open. So as soon as the defrost thermostat opens at around that 65 degree temperature, then it will terminate defrost, or 10 minutes, whichever comes first.
So you're saying the Trane equipment's actually sensing the coil temperature, and it knows when to come out of defrost based on that sensor.
Yeah, once the resistance is back within range for a coil above freezing, it will go back into the heating mode.
Another thing that I didn't realize is on the defrost settings, there's a 30-minute, 60-minute, and 90-minute setting. But what that is that's actually telling the board when to check whether or not the defrost is open or closed. Those are normally open, so if that defrost sensor is closed on the Carrier, that's when it's going to go into its 10-minute defrost. So the 30, 60, or 90 is how many minutes it will take between each time that it checks the actual sensor to know whether or not it needs to go to defrost.
Trane doesn't have any of those adjustable settings. It does it on its own. It has its own algorithm. When it's freezing, it goes into defrost. When it's not.
So whenever that coil drops below 34 degrees,
once it drops below that temperature, I think it'll go into defrost. There's a set time after that. I can't remember what the set time is. It might be 20 minutes after.
Okay.
The thermistor goes to that range, it'll go into defrost.
So
it's all automatic. There's no settings that you can change.
So as soon as it senses, hey, I need to go into defrost, it runs for X amount of time, and then it goes into a defrost cycle. At the same time, the entire defrost cycle, it's sensing whether or not I'm ready to come out of defrost based on that sensor.
And once it's back in the range for heat pump, it'll just automatically go back out. So in Florida, a lot of defrost times on Tranes will probably generally last maybe 6 minutes, 8 minutes possibly, or less. It just depends on the climate. And heat pump doesn't run as much in Florida, no matter what.
So it sounds like testing the defrost cycle on a Trane is actually a little bit easier, huh?
Very simple. Simply jump it.
Okay, so there's 2 test pins. You jumper those out, goes through the defrost cycle, unjumper them, and it goes back into normal operation.
Yes.
Okay.
Now, the defrost will not work unless you have 24 volt power. So if you come up to a defrost control board and the little green LED light isn't blinking, you need to find out why you don't have 24 volt power. If you have no power, you have no defrost cycle, period. It will work in air conditioning, but it will not work in heat.
That's a really good thing to note. On most boards, you're going to need a constant 24 volt source of power, whether it's a blower board, a defrost board, pretty much any type of board, you're gonna need that constant 24 volts present. Another fun thing I want to go over is checking the charge. So we went over the process on how to check the refrigerant charge and heating on the Carrier system. What's different about the Carrier versus the Trane equipment?
Well, placement of the true suction port, you pull the side panel off of a Trane, and the newer ones, the really, really old ones prior to like 1999, 2000, they have the charging ports on the outside in addition to the king valve ports.
So we're talking the side panel near the reversing valve?
Yeah, on the side panel near the control panel where you can see the reversing valve and everything, in the middle pipe that goes to the common suction is going to be the little port. You put your suction line on that and you leave your liquid line connected to your liquid line port. The metering device is well within the machine, well away from that. So you actually do have subcooled liquid coming back to the outside unit at that point, and the hot gas the same way your discharge goes inside. All that's the same, it's just where the ports are a little different, where the metering device is a little different.
So Carrier has the piston, which is right before the liquid line service valve. So on a Carrier system, you can't check your liquid because it's after your piston, so it's not your liquid line anymore. Again, this isn't heating, so you actually just checking your discharge pressure and your common suction pressure. Whereas on Trane, they have the TXV inside of the condensing unit, so you're actually checking a subcooled liquid.
Yes, and you have probably 3 or 4 feet of pipe before the metering device from that point. So you are true liquid, subcooled liquid at that point.
Carrier equipment, the reversing valve is energized and cooling. How is that on Trane? Defrost cycle, we saw the fan drop out. Is that the same? The fan drops out, that whole process?
Yeah, on most equipment, all the defrost cycle is the same. Anytime you want to defrost something, you want the outside fan to shut off. Even Rheem, Carrier, Tempstar, which is a Carrier brand.
Yep.
Bard, different ones. Like Rheem and Bard will energize the reversing valve in heating. So they're different in that aspect, but the actual defrost cycle across all equipment is going to be the same. Like the function of it, turning off the fan, reversing the gas, turning on the heat strips, that all stays the same. How the boards read and how they time and how they adjust those, that's different from equipment. And where you hook up the gauges can differ. That's about it.
The best place to find information, so you're checking your subcool, you're checking your common suction line on a Trane. Where do you find information on how to know whether or not that refrigerant charge is correct?
On most Trane systems, if they're intact and service technicians don't kind of cannibalize the systems, if you pull the door off, there's a packet in an envelope that sticks to the door. You pull that door off, that has all your service specs for depending on what your outdoor ambient temperature is, your indoor entering, the coil, and you go by that chart, by the pressures and everything. And similar to every other manufacturer, you just have to go by their chart and cooling and heating. All that information is within that packet of paper.
Is that going to be similar to the Carrier where it's kind of a overall view, so you have to select your tonnage, you have to select the indoor temperature, and you have to select the outdoor temperature to find what your pressure should be?
Yep.
Anything different on the indoor unit? So on the indoor unit of a Carrier, we have our cool mode TXV, and in heat mode, when the refrigerant cycle reverses, we're still going through our TXV, but it's completely bypassing it. It's not actually restricting it whatsoever.
Yeah.
Is that the same?
Some of them are. The newer Tranes do have that now. I believe they went to Parker Sporlan. The previous ones, they would have a bypass and a check valve, and in order for the gas to work in heating mode, you had to bypass the expansion valve, and it would just literally loop back around the opposite way. When it was in cooling mode, it pushes that check valve in, stops it, and forces it to go through the TXV on the inside or the outside, depending on what mode you're in. is how the check valve works, because there's one inside and outside on the older equipment.
So for you that don't know, and you've always wondered, hey, what is this little weird tube that's kind of bypassing the TXV? What point is that? How is this even working? It actually has a little check valve. Based on pressure, one direction it forces it closed, cool mode on your indoor side, forces it closed, forcing the refrigerant through your expansion valve. In heat mode, it forces the little pin the other way, allowing refrigerant to flow through. So it's pretty cool. It's weird looking. It's a little bit larger than 3/8, right?
They usually are 3/8, but it swells to 1/2 inch where the actual check valve is, but
Yes.
they're not really that cool. They're really, really a big pain. Because sometimes they stick, and that causes a whole nother problem trying to diagnose
It's
something.
very, very difficult.
Yeah, whether or not the check valve is actually seating the way it's supposed to, or if it's not seating and bypassing the metering device. But
So-
they changed that. Everything's different now. They use the same technology that everyone else uses, and they've kind of caught up with the times on that aspect.
When did they kind of switch over? When did you see that, there was that process with the check valve, and then when did you kind of see it switch over to more of a traditional expansion valve?
Maybe 5 or 6 years ago, because some of the original TAM7s that came out, they were still using those even with the electronic expansion valve. So you would still get the coil, and inside the apex of that coil, you would see the big bypass coming around and everything. And they just did away with that and put the new TXVs in, and now they bypass